If you guys took a look at that demo that I did, basically what I did was I put a sparkler in a drill and you saw sparks flying all over the place. And then if the object is rotating, let's say clockwise, if you were looking at the sparks coming off of that, they came off like various points you look at, all coming off like this. Actually, that one's not so good. Maybe like that. And what I want you to realize here is that these were all tangent to the path. And if we rotated the opposite direction, what would end up happening is that you would get your sparks coming off still tangent, but they would be in the opposite direction. So you can have them going one way, you can have them going the other. Now the whole point behind this is the path of these sparks. Basically what it did was it showed us what the direction of the velocity is at any given instant in time for an object moving in a circle. So if we have an object that's following a circular path, it is always moving, but it's always moving in a different direction. And that's what causes it to be a circular path. The fact that maybe it's going to the right, maybe it's going diagonally, maybe it's going down. It all depends upon where you are. So it's very easy to see if we focus on just a few points here. And if this thing is moving, let's say clockwise, the velocity would be pointed in that direction. It would be pointed down here, it would be pointed that way there, and it would be pointed that way there. And let's do another point. It would be pointed like that there. So all of these are tangent to the circular path of itself. So this is the idea behind velocity, is that we have named it tangential velocity. Sometimes we also call this tangential speed. These two terms are kind of interchangeable in this unit. And essentially, you can always look at a picture and get the direction of your velocity here. Now what I've done is I've drawn each of these arrows to the exact same length because we don't expect our speed to be changing here. We're in uniform circular motion, but the direction of motion always is changing, and it's always tangent to the circular path. Now in terms of trying to figure out how fast something is moving, basically we've always thought about how fast something is moving as a measurement of distance over time here. Now, if we kind of trace the distance around the circular path, what it is the circumference of the circular path. And if our objects are moving in a circle, their path has a radius, r, so that distance would be 2 pi r. And the time that it takes to do that, one full cycle, is the period t. So we can write our tangential speed as v equals 2 pi r over t. That's how you solve for velocity or speed in uniform circular motion. Now one more thing, because frequency is 1 over t, we could actually rewrite this in terms of frequency if we want to. We can also write it as 2 pi rf. It's up to you. They're the equivalent formula. Both are, I would say, equally acceptable.